Welcome to the session 8 on machine learning course. So the topic under this particular session is expectation maximization algorithm. So myself Naveen Mukkapati, assistant professor in computer science department. Coming to the aim of this particular session is to familiarize the students with concept of EM algorithm, and coming to the instructional objectives under this particular session is this one be designed to discuss the basic overview of EM algorithm and discuss the general version of the EM algorithm, and the learning outcome of this session is at the end of this particular session the students will be able to describe the EM algorithm. And coming to the topics which are covered under this particular session is a basic overview of EM algorithm and the general version of the EM algorithm. And coming to the basic overview of EM algorithm, so generally we are using this particular EM algorithm to find the latent variable values. So here the latent variables means, so the variables which are not able to observable or which are not able to infer at the particular moment of time. So here those variable values are inferred from the already observed values. So this is one of the use of our EM algorithm. And another one is this particular EM algorithm is the basis for many unsupervised clustering algorithms. Actually we are having supervised and unsupervised as well as reinforcement learning techniques. So in that unsupervised is for the clustering. So in case of the unsupervised we have data without labels. So here our EM algorithm is the basis for many of the unsupervised clustering algorithms, and it's also used for train the Bayesian belief networks as well as radial based networks are also trained. So these are the some of the uses of our EM algorithm, and most of the cases the data which we have is observable data. In some of the cases the features which we have in our data set, they may be unobservable, or in some cases there is a chance of missing values in our data. So to fill those missing values and to get the unobservable values, we simply apply this EM algorithm. And coming to the flow diagram or flow chart of this EM algorithm, so here this is flow diagram of our EM algorithm. So this is the starting state. So here we simply define the latent variables. It means that whatever the data features we have, in that we need to identify what are the latent variables or latent features. So we simply define them, and after that we simply give the initial guessing values for them. So here the initial guessing is done by the available values only. So it means the available values means generally in our data set we have observable data and unobservable data. So here with the help of the observable data, so we simply give the initial values for our latent variables. So the latent variables are the unobservable variables. Okay, so after initial guessings, so we simply check that our stopping iteration. So here we need to check that either convergence is here our initial guessing values are converged or not. If initial guessing values are not converged, then we need to go for the E step. Here the E step is the estimation step. So after estimating our latent variable values, we simply go for the M step. So the M step is the maximization step. So after completion of the maximization step, once again we need to check that our stopping iteration. It means that we need to check that our here our guessing values are converged or not. So if the stopping iteration is our stopping criterion is satisfied, then we simply show the result and end this particular one. So this is the flow diagram or flow chart of our EM algorithm. And coming to the explanation regarding this particular EM algorithm, here our EM algorithm mainly composed with 3 steps. So the step 1 is in the step 1 we need to set the missing or incomplete data and other set of starting parameters. It means that here our EM algorithm main aim is to get the values for our missing or incomplete data. So here with the help of the starting parameters we need to give those values. So in the step 1 we need to set that what are the missing or incomplete data we have, as well as we need to take the starting parameters, and here we need to assume the initial values of the parameters are generated from the specific model. Here we simply use one of the model, and with the help of that particular model we simply generate the initial values for our missing or incomplete data. This is the step 1, and coming to the step 2, in the step 2, so based on the observable values from the available data, and we will estimate the values for the unobserved data or missing data. So here whatever the starting parameters we considered, so with the help of these starting parameters and whatever the observable data we have, so based on this we simply estimate the values for unobserved data or missing data. So here this particular step is known as the expectation step, or we simply call this as the E step. Okay, so it means that in the expectation step or E step, so we simply estimate the unobservable data by using observable data and whatever the starting parameters we have. And coming to the step 3, in the step 3 we are doing the we are following the maximization step. So here by using the data generated in the E step, we will update the parameters and complete the data set. So it means that in the previous step whatever the unobserved data is estimated, so we simply use that particular estimated data, and whatever the parameters we have, those parameters need to be modified. So here, so with the help of this unobserved data which we are estimated, so we simply do the completion of our data set. So after getting the complete data set, so we simply do the updations of the parameters. Here updating of the parameters is treated as the minimization step, or we simply call it as the M step. Okay, so here this one is used to update our hypothesis. Okay, so here the hypothesis is nothing but whatever the starting parameters we consider, those are taken as an hypothesis. So that is initially taken. So that initially taken hypothesis is updated in our maximization step. Okay, so these are the 3 main steps which are in our EM algorithm. And after completion of this particular M step, we need to check that our guessed values are giving the convergence or not. If the values are not converging, then we need to repeat these steps. It means that we need to do the updation of the variables. It means that we need to repeat the E step. So after that we need to do the updation of the hypothesis, that is the M step. So this particular one is repeated until whatever the values we guessed, those values need to give the converging. Okay, otherwise we need to repeat these things. Okay, so this is our EM algorithm. And coming to the general version of EM algorithm, so we know that here our EM algorithm is used to find the unobserved data. So here I am considering x as one of the vector which is having x1, x2 up to xm as the instances. That one denotes the observable data in a set of m independently drawn instances, and z is a set of z1, z2 up to zm. So that this one denotes the unobserved data in these same instances. It means that if we are considering one of the independently drawn instances, so in this capital X is indicating the observable data and capital Z is indicating the unobservable data. So here our total data set is nothing but Y, that is union of these two sets, observable data union unobservable data. So here with the help of our EM algorithm, we need to identify that Z values. It means that after identifying the Z values, we need to form the complete data set. This is our aim of our aim in our EM algorithm. So here whatever the unobserved data we have, that is we denote that one as the Z. So here this one be treated as a random variable, so whose probability density function depends on the unknown parameters theta and the observed data x. So just now only we discussed that. So here whatever the unobserved data we have, that unobserved data is estimated with the help of the initial parameter values as well as observed data. So here also we are considering unknown parameters theta and observed data x. With the help of this we are guessing, or we are initializing, or we are estimating unobserved data z. Okay, so here what are these unknown parameters theta. Here unknown parameters theta are nothing but mean value.